This is Tyler Faulkner with Carlson Software. We're going to be going through lab number 6 here on our Elements Mind Design course. This is going to be our introduction to Carlson. The other video is going to go through some basic introduction to using AutoCAD, so we're not going to be covering as much of that in this video. But our main deliverable that we want to produce from this lab are 8.5 by 11 inch plots of the following. So we want to see geologic columns located across the property. We have a few of them already marked out for you. I'm going to show you how to create one of these plots for these two drill holes. Anything shown here in blue, you're going to be doing on your own. So I'm just going to show an example and then you do it to follow up. Showing those, we are going to do a plan view of the property with our borehole locations labeled in a way as to distinguish core holes from other drill holes. We're also going to show where the boreholes that were used to create the geologic columns were. We're going to add a label to those. The last thing we're going to do is make a contour map. I'm going to show you how to do this on a 2-foot interval, and then you're going to create one on a 5-foot interval. All these plots are going to include a title block, so you need to have a name for the print. You need to include some details, just simple description, date created, scale drawn by, and things like that. So you also include a report describing the site, which I'm not going to be going over with you. You guys will be doing that on your own. So mark that one out. But we'll go ahead and jump in here. You have already been provided with a CSV file of your drill holes. Let's go ahead and take a look at those. Before we do anything inside of Carlson, it's good to understand what we're working with here. This sheet has already been formatted for you, so you don't really have to worry about adding things in here, changing cell styles or anything like that. So let's talk about some of the information that we have. So we've got a header line that tells us what we have. The first thing I see here is my drill hole name, and I want you to notice that the first few rows here, let's grab them there, this is all relating to a single drill hole. So we've got several different types of strata in here. So we have the first layer of till, the second layer of overburden, A-seam parting right on down the list there. So just all this information is tied together. There are many different ways we can import drill hole data. This is just going to be one way, but you can always customize these formats as needed. Column number 2 is just the drill hole type. I can see most of these are type 0, but if I scroll down a little bit further, I see a type 2. And the main difference between the type 0 and the type 2, notice for the type 0s, we don't have any of this quality data. We don't have moisture, ash, or BTU, anything like that. The type 2s, we do for most of them, not all, but some. Primary difference there are type 0, that's going to be a rotary hole, and type 2 is our core hole, where we've actually retained those cores and we've been able to keep the coal separate so we can run some tests on it and get some of this information out of it. The next 3 columns, we have easting, northing, and surface elevation. So this is kind of like our X, our Y, and our Z coordinate for the very top of the drill hole. Notice how these do not change as we go down the drill hole. So those three all need to be the same for all the rows in that hole. Next 2 columns we have here, we have a bed name as well as a strata name. Now, the strata name is pretty simple. It's just very simply what type of material is this? Is it coal? Is it parting? Is it waste material? Things like that. The bed name is more often used for a grouping of the strata. Let me scroll down to one of these, and we can see here I've got, in this drill hole, I have 3 occurrences of the A-seam where it was broken up for whatever reason. If I were to try to import these strata names and I didn't have this bed name to group them together, this would actually throw an error in the program. It would have trouble actually interpolating between different drill holes. So basically, if you have a repeat of any strata name, they need to be grouped together with the bed name. You can call the bed names whatever you want. Oftentimes people use a strata name to just say what it is, and the bed name is used to give it a more localized name. This may be the Sewickley seam or the Pittsburgh seam, things like that. The next thing we have on here is just the thickness of it. Everything in this lab is going to be referring to English units. We're not doing anything metric here, so this thickness is going to be assumed to be feet. Nothing too crazy there. The next thing is actually the bottom elevation, and we actually don't need to have this in the spreadsheet. We don't need to delete it out. I want to show you how we can import this information without changing our spreadsheet itself. One of the last reserved keyword names here is we have a key column, and this is just basically how the program is going to distinguish between what is waste material and what is the ore, what's the stuff we're trying to mine out and actually sell. So in our case, anything that's marked as an A seam or a B seam, that's our coal. That's going to be marked as yes, everything else is no. So, the last 5 attributes we have in here, these are going to be user defined. So when we first start this up, try to import the drill holes, the program is not going to recognize these. We're going to have to define these on our own. Just various coal qualities. We have moisture, we have ash, BTU, which is British thermal units, sulfur and sodium. Again, notice how we don't have any of this information for the rotary holes, where all that information was kind of churned up, so it wasn't well preserved. On the core holes, however, we do have values in here. It is not a problem to have blanks, but I do want to point out there is a big difference between a blank or a null value and a 0 value. Here, we just haven't measured the moisture. That's a lot different from saying that the moisture is 0%. So, just going to point that out. We've already got this saved in a particular format. Notice this is a CSV file. That's not a normal Excel file. Usually when we save an Excel sheet, it's a .xlsx, or just an XLS file. So this has been saved in a particular way. If I go to File, Save As, put this in here. Notice when I'm saving the file, I have all these different formats to work from. There's my Excel workbook, which is the default. If you need to ever save one of these on your own, you want to save it as a CSV, comma, delimited. Now notice that Excel actually gives you 4 different types of CSV. There's one here for a UTF-8, there's one here for a Macintosh or an MS-DOS. You're going to want to use the comma delimited. Some of these other ones, they can actually create a problem for Carlson just in the way they're formatted. So we'll keep that as a CSV, save. And Excel will sometimes give you this prompt. Are you sure you want to keep using the CSV format? It's basically stripping out a bunch of Excel formatting in there, so cell coloring and things like that. Just say yes, and you're good to go. All right. So we know the data that we have available to us. Let's jump into Carlson, and let's talk about how we can actually get that imported. I'm going to go ahead and close this out, show you how we can bring this in from scratch. You will have a few icons on your desktop. A lot of them are going to look like maybe this little minecart, maybe this little civil road symbol. They're all going to say Carlson something and then the version. You may have another one in there specific for AutoCAD. We want to make sure that we use this Carlson icon. It does not matter if you go with Carlson Civil or Carlson Mining. It just controls which of the commands are shown to you right up front. So I'm going to go ahead and bring this up. I am using Carlson 2018. If you guys have an older version, that's okay. Most of the commands are going to be exactly the same. There just may be some dialogues that look a little bit different. We'll give this a moment to start up. I know on some of the school computers you may actually be prompted to close the program and open up AutoCAD once. If that happens, just do what it tells you. Close Carlson, open AutoCAD, close AutoCAD, and then open Carlson again. You may also get the drawing startup wizard. If you get that, you can just go ahead and close it out. We're going to make this thing from scratch. So let's start off. Before we do anything, I just want to get my drawing set up. I want to get it saved to a particular spot so I know where all my files are going. So before I do anything else, I'm going to come up here to say File. I'm going to do Save As. And I'm just going to pick wherever I want to save this. Let's go Software, this in Training. To keep our files organized. I'm going to put this in a new project folder. I'm just going to call this my example folder. So everything is going in example. I will strongly encourage you, anytime that you save a file of any type, make sure you know where it's going, because if you save your file somewhere, 20 minutes later you need to use that file or something and you can't find it, it just gets frustrating. So also just call this my example drawing. Save. Okay, so now the program knows where all my files are going to go by default. Now, I told you when I started this, I opened up Carlson Mining. If you picked on one of the other icons, it's fine. We're just going to need to switch between some of the different Carlson modules. You should already be able to see this Carlson Menus toolbar. If you can't see this for any reason, just right-click anywhere in this area, and you'll probably see a pull-out window where you can choose between AutoCAD or Carlson toolbars. Go to the Carlson group and make sure you've got Carlson Menus turned on. You can move these toolbars around. But the main module that we're going to be working in here is the fourth from the very end. It's a little geology hammer with 3 little pieces of coal there. If you click on that, you'll see some of these pull-down menus change. So now I can see drill hole pull-down menu, StrataCalc, whereas if I was in the civil module, I'd be seeing 3D data, surface, SiteNet. So just make sure you're inside of that geology module, and that's where we're going to be hanging out for the rest of the lab. Most of what we're going to need to do is going to be on this drill hole pull down menu, and we're kind of going to start from the top and work our way down. We're not going to go through every single command here. That'd be a little excessive. So if you're ever curious on what some of these commands do, you can always go check out the help manual. Go to Carlson Help, and there's detailed descriptions there of everything on these pull down menus. So there's the drill hole pull down menu. Every single command is outlined for you. Full description telling you what all the buttons do, things like that. And that define drill hole command, that's actually the first one we're going to be running. So we're going to go to drill hole pull down, and before we can import these drill holes, we have to define them. So I'm going to start this up, and I'm prompted to create a new file here. This is called my drill hole configuration file. Notice that on this screen, we are going to be seeing this a fair amount. Whenever you're trying to create or open a file, you can either make a new one or you can open an existing one. Just make sure you're on the new tab right now. Notice that I am inside of my example folder. If for any reason you're not saving here, you can hit the down arrow. That'll show your recently used folders. Or you can come over here to browse, and then you can just go find the folder that you're after. I am saving inside that example folder. And I like to use good descriptive names for my files. I like to call them exactly what they are. So this is my, at the top here, we see this is a drill hole configuration file. That's what I'm going to call it. Drill hole configuration. I'll say open. I'm just going to get a very simple dialog pop up here. We actually don't need to do much on this dialog. Generally, the only thing we're going to need to change is this key density. So this is kind of a default fallback density if we don't specify it in some other way. This default value of 80 pounds per cubic foot, that's a good estimate for the coal. We're actually not going to be doing anything that's going to involve weight or densities for this lab, so we can actually just leave it as is, and this is all we need to do here. The only other thing we'd use this file for is if we had a very large database of drill holes. This is where we connect it to the drawing, but we're actually good here. We can just say OK. And that's our first command done. So we have the drill holes defined. The next command, I'm actually going to jump down a little bit here. Before we import these drill holes, we can add in this additional setting that's going to control what they look like. Now we can do this after the fact, but it is kind of helpful to do this just right from the start. So I'm going to do drill hole pull down and drill hole lookup database. Over on the left hand side here, I have the drill hole types table. And I've already configured this for my settings. Yours are going to have all the defaults. But essentially what this is doing is we're just going to give a name to the different types. If we take a look at our CSV file, notice that our types are 0 and type 2. And what that's referring to, this means type 0, it's not necessarily trying to match the name. It's going to match whatever is shown in the first row. Next is going to be whatever's in the third row. So I'm going to change these to type 0 and type 2. You can call them whatever you want. You could refer to type 0 as rotary, refer to type 3 as core, and it would have the exact same end effect. The next column here is the symbol that we're going to use to show what the drill hole looks like. By default, we're all using these kind of circle and crosshair symbols. If you want to use something different, you can. So you may want to mark your rotary holes with that just open circle there, that type 4. Just pick whatever you like. It's not really important. The next thing is the size of that symbol. By default, everything is set to 50. That's going to be a fine size for this data set. You can always come back and change those later, just scales the symbol up or down. Next thing on here is the layer that these symbols are going to go on. I really prefer to have my drill holes on different layers so that I can just look at the core holes, just look at the rotary holes. So you could double click on the layer there, type in whatever you like, so drill hole, type 0, really whatever your preference is there. The last thing is the color. And whenever I'm setting the color, I really prefer to use this by layer option so that if I get my drill holes imported and I want to change the color later on, all I have to do is change the color associated with that drill hole layer. I don't have to individually select the drill holes and manually change them. So I like to go with this by layer option, say OK, and we're pretty good here. I am going to save this file. So I'm going to do a save. Again, notice that I'm going into my example folder. And again, we're just going to use a good descriptive name. We'll call this my drill hole lookup table database. Quite a mouthful. Good table database. Do a save. And we'll say OK. So we've got those two commands knocked out, and now we are ready to go ahead and import the drill data. To do this, we're going to go to the drill hole pull-down menu. And I'm going to skip down a good ways to where I see import export drill holes. And we're going to do a drill hole import. Get a prompt here to specify the file format. We're going to mostly be using this custom import formatter. Some of these other ones, if you have predefined formats, you can use those. We're going to do custom import formatter. And then we're asked if we want to use separate drill hole and strata files. In our case, we just have one file that contains everything, so no, we're not using separate files. We'll say no. And we're going to pick the drill hole text file that we're using here. And notice I'm not saving a file, I'm actually opening one up. It's already in here, but it's not in my example folder. I've actually got this stored in the parent folder. I can click this little icon right here to go up a folder. And there I see my lab 6 drill holes.csv. Of course, you can also click browse to find wherever you have that file saved on the computer. I'm going to open that up. I'm going to see this dialog, and mine has already remembered some settings. Yours may have as well if somebody's used the computer before you. But I'm going to kind of wipe this out so we can start fresh here. If you have anything in this used column, just pick one of these attributes and then come over here and click remove till everything has been removed. Okay. So the idea of this drill hole import formatter is to tell the program what each one of these columns in Excel represents. So we can look at this, we know immediately this is the drill hole name or the drill hole ID. But you could have spelled that so many different ways. You could have just put drill hole, you could have put drill hole ID, you could have put some letters in caps. So we don't have a smart way to just automatically detect what's there, so you have to manually tell the program what that column is. On this dialog, down at the very bottom, you can actually just see a simple preview of that spreadsheet. It's just comma delimited, so instead of showing column lines, it's got a comma in there. So I can see my first column is the drill hole name. I'm going to look in this available column for any attribute that matches that, and I can see one there that is called drill hole name. Highlight it, I'll click add, and it gets put over into this used column. And we're just going to keep doing that for every column, but the order is very important. We need to have them in order from top to bottom as they're listed from left to right. So the next one we have here is DH type. And I don't have a perfect match here, but these are all the reserved keywords, and I see drill hole type. That's what that represents. I can also just double click on things to put them over in the used column. So we'll keep right on down the list there. Next I see my easting, which is right there. Next is my northing and my surface elevation. Next I have the bed name. Next I've got the strata name. Next I have the thickness, and that is the thickness of the strata. Notice that I don't have to have matching names. It's perfectly fine for me to use custom names down here. Alright, the next thing I have in here is the bottom elevation of that strata. Now this is where you actually don't need to import that information. As long as we have the thickness of the strata, the program is going to calculate the bottom elevations for us, so there's no need to be redundant here. So instead of deleting that from the spreadsheet, I'm just going to tell the program to skip over that column. So we click the Add Skip button, and it knows just don't import that. Next thing I have is this key column. So it's just the program telling me, is this waste material? Is it good material? I see strata key, non-key. We'll click that. And the last thing I have in here are all my custom attributes. Now in my case, I've already worked through this example, so it's remembered that I've named these. On your end, you're not going to have these predefined for you, so you're going to need to create them on your own. The way we do that is we click the Add Attribute button, and we just give it a name. I'm just going to type in moisture, and then I have to specify if this is a drill hole or a strata attribute. If it's a strata attribute, it's going to change as we move down the hole. Not every strata is going to have that same value. If it's a drill hole attribute, that might be something like the date that the drill hole was actually drilled, or the company that put the hole in the ground. So most of these are going to be strata attributes. I've added my moisture. I'll do the same thing for the ash. Same thing for the BTU. And the sulfur. And lastly is the sodium. All right. Now, if you do get anything out of order here, which is easy to do sometimes, you can reorder these things. So let's say my moisture was not in the right spot. I can select it and use the green up and down arrow buttons to move them back to the right spot. So take just a second to make sure that you have the correct order here. Just double check it. It's very easy to get these things out of order. A couple of other things on here. I have to specify the delimiter that we're using to mark the columns. And because this is a CSV file, which stands for comma separated values, we do have a comma delimited file. That is actually a good talking point. In our Excel sheet, we've noticed that we formatted these numbers. None of these numbers have commas in them. I know Excel gives you the option to add commas in there. That can really create a lot of trouble for these CSV files. So just make sure you don't manually insert any commas, because then the program would think that's going to be a separator between columns. So we're doing comma delimited. The header lines to skip. We do have this first row here. That's header information. That's not actual drill hole information. So we don't want to try to import that. And that's the only thing that we'll need on here. All these check boxes we're going to leave unchecked. The dip change distance, we're not going to be messing with any of that. So we could go ahead and say OK. If you like, however, you can click Save As to save all these settings. So if you move to a different computer, it doesn't remember your settings from the last time, you can pull these up. And I'm going to call this exactly what it is, my import drill hole settings. Just in case we came back here, we could load these settings up and it would populate this back for us. So I'm good there. I'm going to say OK. I'll give the program just a minute to think there. And there it says it's imported 379 drill holes. That's great. But I don't see anything on the screen here. That's mostly because I'm not looking in the right spot. I'm looking somewhere off in left field. Simple way that I can zoom to the extent of everything that's in the drawing. If I will double click the mouse wheel, it will kind of zoom into where I need to go. The other thing I could do is in the command line, I can type in the letters ZE, and that also does a zoom extents. Now because I'm on a projector setting, having some things kind of jump up at me. That's going to drive me crazy. So let's turn some of that off. There we go. So it stops jumping around. All right, so we have our drill holes imported, but notice that these are all looking pretty much the same. If I zoom in, I can see a difference. But one thing I'm going to want to do is just change the color of one of these drill hole types so it stands out a bit more. I'm going to look at my Layer Properties Manager. Just type in the word layer. And there I see my 0 layer, my drill hole type 0, type 2. I have a template drawing open, so I have an extra one in there called plotting. But notice type 0, type 2, they're both set to white. I'm going to change my type 2, which those are my core holes. Change those to a red, so those stick out at me a little better. All right, much easier to see, so that's good. All right, so we have our drill holes drawn in here. before we do anything else, go ahead and save the drawing. Now let's take a look at our lab once more just to see what are we trying to produce here. So we want to see 8.5 by 11 inch plots of the geologic columns located across the property. So there's 2 individual drill holes here that I want to see just drawn on a side view. Let's go ahead and draw those in. But first I need to actually find those drill holes. Now notice here, well, I don't have any labels. I could go into the Excel sheet and find the coordinates and look for them that way, but that's not a really efficient way of doing it. So the way that I'm going to find these, first get the name. I'm looking for drill hole 99076C. I've got a utility in here that's going to help me find that drill hole. So I'm going to go to the drill hole pull down menu, drill hole utilities, find drill hole. Enter the name of the drill hole to find, and I do need to type this in perfectly. So I've got DH99076C. Press enter. And it's just going to point this arrow. I'm still zoomed out a little bit, so if I put my cursor right at the tip of that arrow and zoom in, there's the drill hole. Now before we actually plot these things, we're going to want to make sure that the information came in as expected. In my case, I didn't get any error messages, which is a good sign. If you did, you may need to delete the drill holes, repeat that last command, and make sure everything's good. But just because I didn't get any error messages doesn't mean there's not a problem. I'm going to double click on the edge of this drill hole, and that's going to bring up the edit drill hole dialog. This is telling me everything that's in that drill hole, and here I can see all the strata names, all the values, the thicknesses, the key, non-key, status, bed names, things like that. And then I've got a checkbox. This just tells me, are there qualities associated with that particular strata? If I double click on one of these rows, it brings up another dialog, and this is just showing me all the quality information specific to that strata layer. Everything looks good here. If anything doesn't look correct, maybe I've got some weird strata names, maybe I don't have any of the key columns checked, none of the qualities are checked, I'm going to want to delete the drill holes, import them again, and make sure all my settings are correct there. At this point, I could make changes if needed. For example, if for whatever reason I wanted to change one of these strata names, I could type in a new name, click save, and it would do it. But this only changes them one at a time, and there is no link back to the Excel sheet. So the Excel sheet we could throw away at this point. It doesn't have any impact on the drawing. So your best bet is generally to save any of your changes in the Excel sheet, re-import them. If we do need to make a change in the program, we can do that, and then we can actually export a new Excel sheet. So we always want to make sure that we've got our up-to-date database. I'm not going to make any changes, but actually one other thing there, I need to just verify this is drill hole 99076C. So we're good there. I'm going to draw a simple circle around him just so I can know where he's at. And then I'm going to go find that other drill hole that we're looking for. So this is going to be drill hole 94117P. Drill hole pull down, drill hole utilities, find drill hole. DH97117P. And no match found. Let's see, make sure I spelled that correctly. Oh, sorry, 94117P. DH94117P. Oh, right there it is. Okay. So I'm going to mark these drill holes in a particular way so that I know which ones they are. Simple way I could do this just to keep an eye on them. I could just put a circle around them, but what I really want to do is add a text label to these drill holes. And I could manually type in a piece of text. I could use draw pull down menu text command, type in the name, but we also have a more automated way to do this. I'm going to go to my drill hole pull down menu. And if I look down here, I can see I've got draw drill hole text. I've got 2 commands that are going to let me do this. I've got the standard drill hole text command as well as the drill hole text formatter. This one's very simple. It's just kind of check a box for what you want to see, but it's a little more rigid. You don't have as much control. The text formatter lets you control a lot more information. We're just going to go with the standard drill hole text command. So I get my dialog that pops up here for me. Quite a few options. I'm not going to go through every single one. First thing here is the text layer. You can type in a new layer for this text, but really what I like to do is just put this on the same layer as the drill hole itself. So it keeps things together. I've got a text size, which I can scale up or down as needed. I'm going to use a text size of 50. If we need to change that later on, we can. Then all these checkboxes, these are just extra things that we can add for this label. I may just want to see the drill hole name itself. Maybe I want to see the coordinates, strata names, whatever. For this simple example, I'm just going to label the name of the drill hole. So he's got them there. Next, I can add the strata elevations. I don't want to see those. I don't want to see the strata thicknesses, so I set those to none. Don't want to see strata depths, none. Let's see, my text offset I'll set to 25. It's just going to make sure the text isn't right on top of the symbol. It's going to be offset a little bit. The strata to include, I'm going to leave that set to all, but again, I'm going to skip over some of these extra prompts. We're really breezing through what some of the options we can do here. The rest of these, I'm going to turn off use parameter file. I'm not really worried about any of these checkboxes, whether they're on or off. I'm going to say OK. And I'm prompted to select the drill holes to label. So I'm going to pick that drill hole, that drill hole. Those are the two that we're interested in. I'll press enter. I get a dialog here asking for any of the attributes I want to label. I don't have any of these picked. If any of these were highlighted, I would click clear. I'm going to say OK. And it just drops a text label on there for me. We picked a text size of 50. You may think that's a little too large. That's fine. Set it to whatever you want to see, but now I've got a label. I know exactly which drill holes I'm looking at. So we're good in that regard. We're going to go ahead and save our drawing again. Save early, save often. Now the next thing I want to see here is a side view of these drill holes, something a little more graphical. To do that, I can either line these two drill holes up by just connecting them with a line, or I can draw them individually. For what we want to see in this homework assignment, we want to see these drill holes lined up so that we have the proper spacing between them. The way I'm going to do that is just with a standard polyline. I'm just going to do draw pull down 2D polyline. I'm going to skip over the settings, leave them as is, say OK. I'm going to put this first point right at the center of that drill hole. You may need to turn on your snap settings. I've just got this endpoint snap turned on. That's what's getting me there. Click once there. The second one I'm going to put right in the center. Let's see, it's actually giving me some trouble there. Let's turn on our snaps for the center. There we go. So I've got just a standard 2D polyline, nothing really special about it. I may want to put this on a different layer. Let's make a new layer here. I'm just going to call this our geologic column. Call this location line. As descriptive with that as you want. Color isn't really important here, just as long as we know what that is. Alright, I still have that line picked. I'm going to do right-click properties. I'm going to change it from the drill hole type 2 layer, put it on that new layer. Specific layer names are not as important here. Those are more so for you. You're not going to be graded on what the layer names are. So we know where that is. Now we're going to want to draw these drill holes next to each other in a side view. To do this, I'm going to go to my drill hole pull-down menu. I'm going to go to Draw Geologic Column. Now there are quite a few settings on this page. The settings that I have configured here, I've kind of played around with this a few times, so this is going to be a good start for you. But this can be kind of an iterative process. You can draw it once, get some settings, and say, well, I don't really like the size of that text. I don't like the vertical scaling here. So you might need to go through this a few times. I'm not going to go through every single setting here. We're just kind of getting a taste of what we can do with the program. But we'll be sure to touch on the ones that are going to be necessary for us. First thing up at the very top here is the draw settings. So do we want to draw these drill holes in 3D? Do we want to draw them on a 2D grid, or just small individual ones next to the drill hole symbols? We're going to want to do this on a 2D grid. We're looking for this from a side view. Align horizontally by. This is going to be the space shown between the drill holes. I'm pretty much always going to want to use this projected option. That's going to actually account for the true distance between the drill holes. If I use this individual or this lineup, it's going to totally ignore the true space between them. The next option is align vertically by. I want to always align these by elevation so I can see how the elevations between the drill holes change. If I wanted to match this up so that a particular strata is shown as being flat and they actually move the drill holes up and down, we can do that as well. I want to make sure I turn off this option for draw on fence diagram. That's actually going to expect to see a pre-existing grid. That's not going to work for me. Next thing I have down here is the horizontal as well as the vertical scale. This is going to control the size of everything else. I'll pretty much always leave the horizontal scale at 100, and I'll change my settings to match up. And what that's doing here, if I look at my column width scaler, my text size scaler, my hatch scaler, if I were to take my text size scaler, for example, 0.05, if I multiply that by my horizontal scale, I get a value of 5. That means my text is going to be 5 units tall. The column width scaler, which is the width of the drill hole itself, it's going to be drawn as 5 units wide. The vertical scale just controls the vertical exaggeration of the drill holes. If the horizontal and vertical scale are equal, it's going to be a 1-to-1 true ratio. If I set this vertical scale down to half of the horizontal scale, maybe a little bit backwards from the way you'd expect, but that's actually a 2x vertical exaggeration. So these drill holes are going to be stretched out a little bit. And if we're trying to make this look nice on an 8.5 by 11 sheet of paper, 2x vertical exaggeration is going to be fine. Skipping down a few here, not worried about these next 3 options, but I do want to draw my strata connections. So this is going to say, just draw a line between the 2 occurrences of the coal seams and show me how they change from drill hole to drill hole. Next, I'm going to go change the background grid options. I know we're not the most exciting part here, but this will have a big impact on the way this thing looks. But the grid options, this is just going to control a grid in the background to keep track of the distances between the drill holes, maybe the elevations as well. And I've got a few settings shown for me. For example, on my grid interval, this is going to be a 25 by 25 grid. This is going to be 25 grid horizontally, vertically. Every 25 feet of vertical change, we're going to have a new grid line. The text interval means just label the elevations every 50 feet. Got a few options I can show here. I just want to see the elevation axis and the station axis. If I turn on the depth axis, that's going to tell me the depth in the drill hole. It's going to add some extra labels on the drill hole itself. It's going to look a little rough. Next, I have the station interval. That's going to add the grid line and the text along the horizontal distance between the drill holes. I'm going to set that to 50. I know that'll come out fine. Next, I have my grid layer. So what layer it's going to put that grid on. I always put it on a layer called Fence GeoGrid. You can call it whatever you like, whatever works for you. Next, I have the grid style. I'm going to want to use full grid lines. I do also have the option to just use grid ticks or use ticks and dots, but grid lines, very easy to see, so I'm going to stick with that. I'm good on my grid options. Moving down a little bit here, I've got my label settings. Quite a few labels I can add in. If I turn on no label, it's just going to draw the drill holes themselves. It's not going to tell me specifics of it. But things that I do want to see here, I want to label the strata, and I want to add in the thickness of the strata. So that's really what I'm concerned with. I have a pull-down menu here that tells me which strata I actually want to label. And if I'm only interested in the coal seams, I can change that to key only. It makes the drawing just a little less busy. So it's an easier one to work with. 2 other options I've got extra settings here for. I've got the label options. These are kind of some specifics. If I want to see prefixes on these labels or control the number of decimals, I can mess with that. I'm really not concerned with this, so I'm going to say OK. But next are the drill hole options themselves. This is going to allow me to label the drill hole name, the drill hole surface elevation, really anything you want there. The main thing that I'm setting up, I want to change that drill hole text size scaler to 0.07. So it's going to be a little bit larger than the other labels. And again, I know all this just because I've gone through a few iterations of changing the values, and I found that this works out well. All right, moving further down. I don't necessarily want to label my beds. I just want to label the strata for this example. The strata layers, I want to put these on individual layers. So the coal will be on its own layer, the overburden will be on its own layer, things like that. I do want to fill these with a hatch, and I'm going to ignore these last two settings here. So quite a few settings that we're configuring here. As you can imagine, it'd be kind of a pain to have to set these up every single time. So you may want to click save and just call this, make sure I'm putting this in the right folder here. So now I'm in my example folder. And again, we'll just call this exactly what it is. So the geologic column settings. It's .gcl file. I'll say OK. And now I'm told to select my fence alignment polyline. That's going to be this polyline that's connecting those drill holes. I'm told what is the maximum drill hole distance from that polyline that I want to pick up. So these two drill holes, they're right on it. The value there, they're 0 feet away from the polyline. This drill hole, however, it might be 200 feet away from the drill hole. So I'm going to want to set this to something so it doesn't pick up anything extra. I'm just going to type in a value of 10, which is just going to be those two drill holes. I'll press enter. So that's one way of kind of filtering out which drill holes are shown on this polyline. But I still have to actually pick which drill holes are eligible. So if I just pick those two drill holes, I know that it's not going to be able to pick up anything else. It's kind of a safe way to draw it. I'll press enter. I get one more prompt here asking which attributes I want to label. I don't want to see any of these right now. I'm just going to say OK. I get the next prompt asking which strata I want to connect. So if I wanted to connect the overburden layer between those two drill holes, I could select that. But I'm really interested in my two seams. So I'm going to select my A and my B seam. I'll say OK. And now I'm told to pick a location for the geologic column. I'm going to zoom out here. I'm going to put this somewhere off to the side, kind of in blank space. It's drawn them in. And now I can see what I have in here. So I've got my two drill holes with the labels up at the top. Notice that those labels are slightly larger than these others. And I've got, in this drill hole, 2 occurrences of that A seam, actually 3 occurrences. I've got 1 occurrence of the B seam there, that's fine. So just a pretty simple layout. I'm not going to get into controlling the coloring of these or controlling which layers this drill hole information is shown on. On that note, if I look at my layers, notice I now have an A seam layer, a bottom layer. I'm going to stick with those as is. You can control those if you like. But that's just a little too detailed for this lab. So that's going to be a very simple layout of the drill holes, and that is going to satisfy that first point as far as showing the geologic columns located across the property. And you are going to work on these next two on your own. So you're going to find where those two are. You're going to draw the line between them and draw the drill holes just as we did it. You can change the settings if you like, configure those however you need. And the next thing we're going to focus on is creating a plan view of the property. So the plan view of the property is really going to be nothing more than just changing the label on these boreholes. Well, actually, we're just trying to distinguish core holes from the boreholes, which we've really already done in here. So we've got, our rotary holes are these white circles, whereas the core holes are these red kind of crosshair symbols. So that's kind of already been done for us. Now the other thing we need to do there are to kind of mark the boreholes that were used to create the geologic columns, which that's something else we've already done. Now when we are putting this into a plot, we may need to change those label sizes. I'm going to save all the plotting for the end there. So we've just got these really formatted the way we want. And of course, you will need to also have those 2 other drill holes labeled appropriately. So we'll leave that for you guys to do. So that just needs to be plotted out. But the next thing we need to do here is to plot a plan view of the surface topography with a 2-foot interval and a 5-foot interval. Now we're going to be doing a kind of intermediate step here, and we're going to talk on how we can model surfaces. We may have already done this in another program, but we need to learn how to make those surfaces within Carlson. And those surfaces in Carlson, we take two types of files. We can use grid files, or we can use what are called TIN files. Those are triangulated irregular networks. Grid files, you can imagine that if we had a surface, we had a mountain. A grid file, if you were to take a large, it's kind of like a fishnet. If you were to take a fishnet and drape it over this mountain, anywhere you have crosses on the fishnet where these strings tie together, you would take an elevation at that point. If you have big holes in the fishnet, you're not going to get a lot of detail, kind of like your features or your fish are getting out of the net. If you've got really small holes in the fishnet, you get a lot more detail. The main thing with that, though, is that the more detail you have, the bigger the file gets. So we need to find a balance here. This will all make more sense once we actually make it and we can view it. But when we're making these grid files, we're going to first want to have a boundary for ourselves. I'm going to start by making a new layer. I'm going to call this my boundary dash grid. Always good practice to use nice descriptive layer names so there's no question about what we're drawing here. I'm going to make that my current layer just by double clicking on that status icon. Now anything I draw is going on that boundary grid layer, and let's actually change that to be a yellow, just stick out at us a little bit better. Alright, I'm just going to draw a rectangle on here, so I'm going to do draw pull down, do the rectangle, and we don't have to be too exact here. Whenever we make a grid file, we just want to make sure that it's going to be large enough to cover the area that we're interested in. If we make this too small and then later on we want to do anything outside of that grid area, we're going to have to repeat all of our steps. So we'll err on the side of covering too much area, and I know that all my drill holes are in here. That's everything that I'm interested in. So to make the grid file itself, I'm going to go to my grids pull down menu. And we're going to go with this very first command here, which is just called make 3D grid file. And actually, before I do that, I'm going to actually isolate some of my layers. I don't want to see these. I don't want to see that polyline. The text itself, I actually would want to turn off. So let's do. Let's go ahead and turn off the layer for that geologic column location line. And I'm going to freeze that, but my drill holes themselves, these labels here, they're on the same layer as the drill holes. So I'm going to need to move those to a different layer. I've already actually got one in here called drill hole label. Let's actually put them on that layer. So I'm going to select those two labels, and I can do this through the properties menu. Let's put them on that drill hole label layer. So now they're on the turned off layer. I could have also used this properties toolbar. So I'm just seeing my drill holes in here and my grid boundary. I'm not worried about anything outside of this. But I'm going to do grids pull down menu, and we're going to say make 3D grid file. Grid file to create. I'm going to just call this my topography grid. I'll do a save on this. I've got a dialog here where I'm going to set all the settings for these grid files. We'll talk on most of these settings. First of all, the source data. What's my input for making the grid file? I'm just going to select entities on the screen. I'm not coming off of any of these other files made for me. So screen entities. Next, I've got a filter for the range of elevations and values to process. The default ranges is from 0.01 elevation up to 20,000. So if I had anything down at 0 or negative elevation, it wouldn't even process that as an input. This is fine. If you do have elevations down below sea level, though, you will need to change that value. In our example, we do not. Next, we have the modeling method. We're not going to get too in-depth with this right now. You're going to discuss that some more in your next lab. But we're going to use this triangulation modeling method. So anytime we have a data point, it's just going to straight line interpolate between data points. There's no smooth transitions between values. It's just exactly what's there. And another thing on the triangulation method, this is not going to extrapolate outside of the area. So inside of here, we can calculate elevations between known data points. Whenever we get out to the corners here, we can no longer interpolate. We would actually have to extrapolate. And on its own, the triangulation method does not do that. So our contours are just going to be within the drill holes, and that's fine for this slab. Next is the triangulation mode. We're always going to leave this on the auto detect. There's some other ways you can tell it on how to triangulate between points, but we're not going to talk about that level of detail right now. Next, we have the inclusion-exclusion areas. We're not going to use these, but if we did want to make the grid just within a certain area, or if we want to just ignore inputs outside of a polyline, maybe we had a property boundary we wanted to use, we could use that, but we're going to ignore inclusion-exclusion areas for now. Next option is we have to set the grid position. We have to tell the program where this fishnet is going to go on top of our topography. And that is why I had us draw this rectangle so we can snap to it and know where this thing's going. And we're going to do the screen pick option. If I already had another existing grid file, it's always good practice to make your grid files match up on top of each other. So I could have used this option to make sure those two match up. For now, we're doing this for the first time. We're going to do a screen pick. And next is the grid resolution. So this is where we're kind of specifying the sizes of the holes in our fishnet. We can tell the program we want to have X number of holes in the fishnet in the X direction and the Y direction, but it's generally a lot more useful to just specify the dimensions of the cell. The default value should be 50 by 50, so every 50 feet we're going to have a data point. I've already tried it out on this data set. That's going to work fine. If you needed more detail, you would want smaller holes in the fishnet, so you would go with maybe a 10 by 10. As a rough rule of thumb, you want to make it so you don't have more than about 1 million grid cells. Anything beyond that, it kind of blows up. Or if the file size gets to be larger than maybe 5 or 10 megabytes, you'll notice it starts to slow down there. So I'm going to make this grid, check the file size, and we'll see how it works out for us. So I'm going to say OK. I'm going to pick my first grid corner, and notice I am going to use my snaps to make sure I get right on the corner there. Again, we can adjust our snaps down here on this icon if we need to. Snap to the bottom left, and now I'm going to snap to the top right. So now that's where the grid's going to exist. And I'm going to select my points, lines, polylines, grids to faces to grid from. And that's why I wanted to turn off those text labels and that polyline, because I don't want to use anything other than the drill holes themselves. So I can actually just window in here. I did actually select the border there. I'm going to want to deselect that border by holding down the Shift key and picking on the border so it's not highlighted. I'm good to go. I'll press Enter. Give the program just a second. I didn't get any error messages, but I did get this writing grid file, so I know that it saved that topography grid. Let's take a look at that just to see how big the file is. My example folder here. And I can see that's only about 300 kilobytes. So that's actually a very, very small file. I could increase that resolution as much as I wanted. I may actually do that here in just a minute just to kind of demonstrate. That 50 by 50 is going to work fine for our purposes. But now that we have that grid file, let's take a look at it in 3D before we contour it, just to make sure it came out the way we expected. To do this, I'm going to go to my View pull-down menu. I'm going to go to 3D Viewer. I want to say I want to look at a surface file in that 3D viewer window. There I can see I have my topography grid. I'm going to say Open. Here we have the 3D viewer window. If yours looks a little bit different, don't worry. For example, this surface may show as all red. You may not see any of the color scales. We're going to talk a little bit about the 3D viewer so you get familiar with that. First, on the top right, we can turn on this color by elevation. It's a good one to mess around with, just so we can see the range of values here. It automatically creates that color scale. So it's showing me that my surface is going anywhere from about 970 up to about 2030 in elevation. If I will click and drag, I can rotate this thing around. If you're not in rotation mode, you'll probably need to click this icon right here, switch to rotation mode. Whenever you're doing that, if your cursor is near the center of the screen, you're going to see an X and a Y cursor. Clicking and dragging is going to let you tilt up. If you get more around the outside of this thing, notice that my cursor changes to that Z icon. Now if I click and drag, I'm going to be twisting around the Z axis. So with that, you can kind of inspect it. this surface is going to be relatively flat to the compared to the overall area that we're covering. So I may want to turn on my vertical scale, change it to maybe a 4, exaggerates it a little bit, 12, get a little better idea of where that slope is actually changing. So just a quick little preview. One other thing, you may also just be seeing this in a wireframe view, and this is actually a really good way to explain what the grid actually looks like. If I zoom in on this, looking straight down on it from the top, I can see a regular grid-like pattern. I can see my little squares in there. Now it actually puts an extra line between it to make triangles out of these, but you can very easily see the grid cells. And these cells are going to be exactly 50 units by 50 units. So you can imagine if we had smaller cells, more detail, bigger file. That's all I'm going to talk about in the 3D viewer for now. There's a lot of other things we can do with this, but that's a quick little introduction. We're never going to be doing any real design work in here, so we can always just close that thing out and we're good. If we did see any irregular spikes in that surface file, anything that's not looking quite right, we may want to remake the grid file and just make sure we're selecting the right entities. But that all looks good. Let's go ahead and contour that grid file. To do this, I'm going to go to my Grids pull-down menu. And notice there's a command right here for Contour from Grid File. I'm prompted to select an inclusion perimeter. So if there was just a small area inside of here that we wanted to show the contours for, that would be my inclusion. I don't have one. I want to contour everything. I'll press Enter. Other option would be an exclusion. Maybe I had an area in here I'm not concerned with the contours. I can pick that, and it would ignore the contours in that area. Don't have it. I'm going to press Enter. And now I'm told to pick a grid file to process, which is just my topography grid. I'm going to open it up. And we've got a few settings here. We can configure this quite a few different ways. We're just going to be going through a really simple example. And the assignment tells us that we want to see this contour on a 2-foot interval. I'm going to show it on a 2-foot, show you some of the things we can control there, and then you're also going to draw it on 5-foot on your own. So up at the very top here, we can see the range of values that are actually covered. So we're going anywhere from about 1960 to 2030. So we can use that to just pick an interval that's going to work for us, but again, it's predefined. We're going to use an interval 2. We are going to put this on a contour layer, and I like to call this contour dash 2-foot. Just a nice descriptive name. We know exactly what it is. It's going to create a new layer for us. Next down here, we have the contour interval value itself. I type in a value of 2. I do want to make sure, however, that this checkbox is turned on. If I turn that off, it means that I just want to see the polyline that represents the 2-foot elevation, which doesn't even actually exist in this contour, so it's not going to draw anything. So just make sure we're using the contour by interval option. There are a few other settings we can work around with here. I'm going to show this to you once with most of these turned off. I'm not going to draw index contours or labels. I'm just going to turn on this reduce vertices. It's a good option to leave that turned on. That just prevents the program from adding in too much detail on the curves in these things. So we've got that default value of 0.01. That's fine. The other option in here, minimum contour line length of 150. So any little island lines, if the length of the contour is less than 150 feet, it doesn't get drawn. You can change that as you like. Last thing is contour zone analysis. That's basically just going to color in specific ranges, makes the map pop a little bit more. We're not going to do that for right now. We just want to see the lines. And I'm going to say OK. See how this comes in. There it drew my lines, and that's just fine. We can see that this is kind of a rough looking contour map. It's rather angular, it's not very smooth, and that's based totally on the modeling method we use. We told it to triangulate between the data points, so we end up with these really sharp transitions where we can see where the triangles were kind of created. In the next lab, you're going to learn how to make contour lines and surfaces that have smoother transitions between values. Another thing on here, we don't have any labels. So I could select one of these contours take a look at the properties. There I can see the elevation is 2022, but I don't want to do that every time I want to inspect. So I'd want to add some labels on here, but I may not want to add a label to every single contour line. That'd get a little bit busy. So I'm going to erase these contours, draw them again with labels, and we'll show how we can create those. Quick way to erase things. Now I've already done a bunch of zooming and panning. If I were to try to just hit Control-Z and undo, AutoCAD's going to try to undo the camera movements. So I need a little quicker way to get rid of this. One way to do this, if I will pick on one of those contour lines, notice it is on that new layer, and I do a right click, I can do Select Similar. That's going to grab all the poly lines on that layer, and I can just hit my delete key, and away they go. So it's a really quick way to select. And there's other ways to do that as well. Let's repeat that last command. So we're going to go to Grids Pull Down, Contour from Grid File. Inclusion Perimeter, I don't need one. No exclusion either. Select my topography grid. I'm going to turn on these two extra options. I do want to see index contours as well as labels on those contours. Let's start by talking about the index contours. Click Setup. Notice that I have an index layer. These contours are going to go on a different layer compared to the main contours. So I'm going to call this one Contour -2 foot, and I'm going to call this my index layer. So every fifth contour, every 10 feet, it's going to be drawn on a different layer. I can set the color here, but again, I do like to keep that on that by layer color. So I can just change the layer color later on. I say OK. Now I've got index contours. They'll show up a little bit different. Next thing are the labels on the contours. I'm going to click Setup. Quite a few more options here. I want to make sure I get the label layer correct. So I'm going to put this on Contour-2 foot. I'll call that my label. Work. There I can pick a text size. I'm going to run with 100. I think that'll work okay, but if not, I'll leave it to you all to come back and get a text size that's going to work out well for you. I mentioned that we may not want to put a label on every single contour because it would get a little too busy. So we're going to turn on that option for label index contours only. And that's actually the main reason that I enabled that draw index contours option. The rest of these are really personal preference. I do like to align the text with the contours. And the last thing on here tells me how many contours I want on each, or excuse me, how many labels I want on each contour. I usually go with 2. We'll run with that. Say OK. Draw them again. And there we go. Now I've got some labels. So I can see it added the labels in. They're large enough that I'd be able to read them, so that's fine. The other thing I may want to change here is just the color of that index layer. Let's go to our Layer Property Manager. And there I can see my Contour 2 foot index layer. Resize this thing a little bit. So I'm going to change that index layer to show up maybe as a cyan. Say OK. And there that just kind of pops out at me a little bit more. So that's very easy to see where those 10-foot labels are. So I could customize that as much as I wanted. But that's going to be fine. We're able to draw contours, draw labels on them. And that's all that I'm going to do for that step. The next thing you guys would do is create another contour map on a 5-foot interval. So we're set up there. The last thing that I'm going to show you how to do is get these different items ready to print. So you may have done this in other classes, talking about how we can print in AutoCAD, but it is a bit of an exercise in and of itself. Before I do anything else, though, let's go ahead and do File, save the drawing, and we're good to go. So now we're going to go to our Layout tab. If you're not familiar with this, AutoCAD allows us to draw everything in model space, and then we can create different layouts to set it up to print. Now, I've already got a template set up for myself. This is just a title block that I like to use that I've spent some time customizing. You guys will probably have to build this up on your own. Just to give you an example of what this would look like, for this example, you can see I've got my contours here. I've got drawn by, I've got a poor name for this layout, but this is essentially what you're trying to make. To show this process, I'm actually going to make a brand new layout by clicking the little plus button here. Go to Layout 2, and this is going to be just a blank sheet of paper. I'm going to select everything on here and delete it so that we can show how to do this thing from scratch. So all I have is a white sheet of paper. This should default to an 8.5 by 11 sheet of paper. If it's not, though, or if you just want to check, you can right-click on the layout, go to Page Setup Manager. I can see Layout 2 is selected, and right there I can see it's an 8.5 by 11, and it's in landscape. That's fine. If I wanted to make new ones there, I can, but I'm not going to get in details on that. If you need more information with messing with the Page Setup Manager, this is just pure AutoCAD stuff, so you're going to have a lot of results if you just Google it. But I'm going to close that, and the first thing we're going to do is we're going to use a default title block, and we can modify that as needed. To do this, I'm actually going to go to my Settings pull down. I'm going to go to Title Block, and there are two predefined title blocks here. I've got T block 1 as well as number 2. You can use one of these if you like, or you can make your own. If you want to Google AutoCAD title block template, you can find plenty of options there you can mess with. I'm going to use just T block, that first one there, and I want to make sure this thing comes in the right size. So I'm going to set the scale to 1. My paper size is 8.5 by 11. I am in landscape. I'll put this on a layer called Plotting, and everything else I should be able to stick with the defaults. I'll say OK. And notice that this just is going to create a 8.5 by 11 border for me. I'm going to want to match this up on the sheet of paper about as close as I can. So I'm going to zoom way in on this, pick a point, and I'm actually going to immediately get a pop-up where I can start typing in values. I'm just going to say OK to that, go with the defaults, and then I'll show you how we can modify that. So there it has drawn in a title block for me. And this one's a little different from usual text entities in that it's an actual block. If I double click on that text, I'm going to get this attribute editor. I can pick my title, and I'll call this example, let's call this our contour map. I can add some other things, for example, the drawn by, I've got my name in there, the drawn date, enter in today's date, and whatever else I want in there, scale, anything else that I need. Say OK, and all's good. Now the thing that I don't have in here is I can't actually see my drawing. I don't have what's called a viewport. We're going to need to draw one of those in. The way I do this, there's multiple ways to do it. I actually just type in the command name for it. I'm going to type in vports. Press enter. And I get a few different options here that I can mess around with. I could do a single viewport. I could do multiple viewports. Now actually for this example, if I do any of these, it's going to want, well, let's just go with a single viewport for now. Say OK. And notice I'm going to be prompted to specify the first corner here. So if I were to snap here, I'm going to get the viewport in there, but I've got the small problem where this is actually overlapping my title block, and that's not going to look good. I'm not going to ever want to draw something that looks like that. So I'm going to select that viewport, and I'm actually just going to delete it. I'm going to show you another way that we can draw in a viewport that just goes around this white space here. This is going to be a slightly different way of doing it. I'm going to type in -vports. So this is going to be more of a command line based rather than a dialogue. And here I can use what's called this polygonal option. So I can click on that. And now I'm going to start drawing a line, just going around my title block. And when I'm done, I'll just press enter. And notice how that's no longer overlapping my title block. That looks a lot better. And now I can just fit this in here. Sometimes it is a bit of a challenge to make things really fit on an 8.5 by 11 sheet of paper. So you kind of got to be smart about how you set your text sizes, things like that. You may even want to reconsider how this title block is drawn in here. You can draw that title block however you want. You noticed on layout 1, I had my own preference where it goes all the way across the bottom there. And now I've just got this nice easy rectangle where I can draw whatever I need. I'm going to leave that to you to pick what you want to show. Now to get this, let's say actually first, another thing, I've got my viewport itself. It's on that boundary grid layer. I'm probably going to want to put that on a different layer. So I'm going to make a new one, and I'll just call this viewport. I'm going to pick that polyline as well as the viewport itself, and I'll put that on that viewport layer. All right. Now something I haven't discussed yet is paper space versus model space. We can draw things actually on the sheet of paper. That's always where you would put the title block, or you can draw things in the model itself. Notice down at the bottom here we have model or paper space, and if I switch between those and I start zooming in, now I'm in model space. Notice now I'm zooming in inside that window, whereas if I'm in paper space, I zoom in and out, now I'm looking on the piece of paper. Same thing if I were to draw a line. This line right here, that's being drawn on the piece of paper. If I switch back into model space and draw a line, now that's actually inside the drawing itself. If I were to go back to this model tab, some settings kind of freaking out on me here. Go back to model space. Notice that I only have that one line drawn in the model itself. The other one was just drawn on the sheet of paper. It doesn't show up in the drawing. And line back there. Yeah, having some trouble with the projector settings. It's the way it's going to show that command line. That's okay. All right, so I've got my contours in there. Another way I can actually jump between the viewport and the paper space, if I double click inside the viewport, it's going to allow me to adjust that. So, and I can still do everything I was normally doing. I can draw things, I can label things however I want to see it. That's fine. And what I want to do is I want to set the size of this scale so that I can see everything that I'm interested in without, and I generally want to put this on a more regular scale. While I'm in model space, I'm zooming around here, I can come down to the very bottom right, and there's a few predefined scales for me. I could do it a 1:1, and that's going to be zoomed in way too far. I could try this on a 1:100, and it's still not going to work out for me quite well. So I'm going to need to define my own scale here. The way I do that is I actually just use the zoom command. There's many ways to do this in AutoCAD, but I'm going to go to the command line. I'm going to type in Z, and now I'm going to enter in my zoom factor. So if I wanted to show a 1 inch equals 500 feet, it's kind of a weird format. I'm going to do 1 inch divided by 500 feet. And then I have to type in this XP, so 1/500th relative to the paper space, and that automatically goes from inches to feet. Type that in, and now I'm at a 500, or 1 inch equals 500 foot zoom. If that's a little too far in for me, I'm going to want to change that up, so I'm going to repeat the zoom command. Say 1/1000 XP. Still not quite enough, so let's try one more. So zoom 1500 XP. All right, so that's going to fit. However, it's still cut off a little bit here. That's where you may want to play around with the title blocks. I'm not going to get into too much further detail there. You guys, you have the tools in front of you, so make it work. Once I have that zoom set to something appropriate, I can lock in the viewport. Down the very bottom right here, I see this little lock symbol. And now if I try to zoom in, it knows that the viewport is locked. It's not going to let me move it around in the drawing. It's not going to ever change my scale. So the only way I could change it now is if I unlocked it, moved it around, and locked it back. So, simple example there. But that's really all there is to it. Once I fill out these things, I can put whatever else I need to on here, and this thing will be ready to print. Now let's just look back at our assignment once more. This thing needs to see a title, some details, so a description of some sort, date created, scale, drawn by. That's got everything it needs in there. Two other things that you may want to include here are a north arrow and a graphics scale. We've got a couple of commands that will help you do this automatically. If I actually go into my civil module, a few other pull-down menus here, I go to the annotate pull-down, there's two commands here that are really helpful, the draw north arrow and draw the bar scale. If I wanted to draw a bar scale, just click on it. I can put this on a layer of my choice, and I could type in what size of a scale I want to see. I know for my drawing, I've got a 1 inch equals 1,500 foot, so I could type in that value, and I can pick between a few different styles. I usually go with this 3-stage. I'll say OK, and it just drops it in there for me. So now that just pops it in. I didn't have to draw that thing manually. It's very easy. This is something you would want to put in the model space. This does not go on the paper. This makes it very easy to know, okay, the distance between these two drill holes, that's maybe 1,000 feet or so. So that's one way you can do it. The other type of entity you can draw in here is a north arrow. So there's a few different north arrows we can pick from that are already in here. Just a quick little library, you can pick your favorite one. And this is something you would generally want to put in the model space if you can make it work. You may need to put this in paper space. It's whatever's going to work best for you. But the rotation azimuth, I haven't got any kind of twisting of the screen, so I'm going to leave that set to 0. The symbol size scaler, this is something where I actually want to specify this on the screen. I can put that on the default layer name, that's fine. I'm just going to say OK. Pick an insertion point. And it's actually not showing me my preview right now, so I'm just going to set a scale factor of 10. And that's still pretty small. I'm not really happy with how big that is, so I'm going to want to scale that up. So I'm going to say Edit. We're going to go to Scale, do a standard scale, pick my tiny little north arrow there, pick a point on it, and let's make that 10 times larger. Alright, still a little small. I'm going to repeat the command just by pressing Enter again. Select that object, pick a point, let's make that 10 times larger again. Alright, we're getting a little bit closer. You get the idea. We'd want to scale that up to a point that we're happy with it. So those are the basics of what we would want to include in this viewport. We'd want to make another layout to show specifically the geologic columns here. We'd want to make sure that all of our text is readable. I'm going to run a little bit long in the video right now, so I'm going to not get into too much more detail, but I do want to show you how we can copy these viewports, or these layouts. If I'll just do a right click on layout number 2, I can do move or copy. I'm going to say we're going to create a copy, we're going to move it to the end. I'll say OK. Notice that it adds it in there. And now inside of this layout, I could make any changes I want to see. So this one might be my geologic columns. Say OK. This one I may, let's see, I'm definitely going to need to unlock that. There, I could zoom in on my columns. Again, making sure that this is nice and readable. I'll leave that to you all to get that scaled properly. Actually, when we're looking at our geologic columns like this, the scale of the drawing is not necessary, because we can actually already see the stationing along the side here. We can see the vertical elevation values. So I wouldn't be as concerned about putting a graphic scale in here. Even main thing is, we have a 2x vertical exaggeration, so that graphic scale may not be as helpful to us anyway. But we've got that down. Again, we'd want to modify this as needed. We'd want to make this look nice and professional, have everything we want in there. But that's really going to be the gist of it. We'll make more of those as needed, show our contour map, show our geologic columns, anything else. Once we have all that in here, I'm going to save my drawing once more, and then we're just going to actually print this out to a PDF. To print this out to a PDF, there's two ways we can do this. If we go to File, pull down, there's a plot command. That's actually the AutoCAD plot command. And inside of that, we can go down to plot. This one gives you quite a few settings to play around with. Might be a little overwhelming. The one that I'm a big fan of is just this PDF command. This is a Carlson command. So if you're using a computer without Carlson, you won't see this. But here I could just say output all my layouts to PDF. This is a little more automated. I'm going to call this my example plot 1. There's a few extra things I can turn on here. I'm just going to leave it with the defaults. I'm just going to say OK. Notice that I do have the option to pick which layouts I want to print. I'm going to leave this set to all. So I'll say OK. I'll give that just a second. And now I've got a PDF that I can scroll through, and that's got all of my layouts right in there. Again, I haven't really fine-tuned these, so I wouldn't call any of these ready to turn in. But that's just an easy way to get those printed out. The other way that I can print these is go to File, pull down, and Plot. Use the AutoCAD plot command. This will give you an option for a batch plot. If you want, I'm just going to plot a single sheet here. And you get quite a few more options. This lets you pick which printer you want to go to, so you could go straight to a printer. My default's just the one in our office. But if I go down here further, I can find straight to whatever PDF writer you have. But what I really like to do is go from DWG to a PDF. Go with that. If I have any other options I want to work with here, you can work with those, but I'm going to stick with my defaults. I'm going to say OK. And this is going to go out to wherever I specify. And I'll call this one example plot 2. Save that. And what this is going to allow you to do, this actually gives you layer control in the PDF itself. So you can give this to somebody that doesn't have AutoCAD, and they can turn layers on and off. This is just a standard PDF reader, nothing really crazy about it. But this is incredibly helpful because you can give this to your manager who just wants to look at the PDF and see what you drew, and he can turn things on and off as needed. That's going to conclude this lab. If you have any questions, you are more than welcome to contact me with questions or talk with your TA. But again, if you have any generic AutoCAD questions, probably your best way to get a quick response is just to Google it. Just use nice descriptive terms and you'll get what you're after. Thank you.